Let's work through the HMS Pinafor problem to find the resultant vector or net displacement vector in group work quiz for chapter 3. The problem is asking HMS Pinafor mean 45 degrees south of west when you say southwest, and then runs aground. How far and at what angle must the rescue ship sail to go directly to the Pinafor? So Pinafor sailed due west for 25 miles and then 50 miles south of west. So what's really being asked for is how does the rescue ship not retrace Pinafor's track, but instead go directly to Pinafor? So we recall that if you graphically depict vectors tail to tip, which actually is what happened in this particular case, then the resultant vector, the single vector replacing both vectors being added, is the vector from the first tail to the last tip. This is the resultant vector, or displacement vector A plus displacement vector B, or the net displacement. The process for the component method of vector addition is 3 steps. Number 1, you must do all vector calculations in x and y component form. You cannot do the calculations in polar form. Then you must add the x components separately, add the y components separately. At this point in time, you do have the resultant vector, but it is in x and y component form. The rescue ship does not want to go the x component and then go the y component. The rescue ship wants to go directly to the magnitude. So for this particular problem, the A is a quadrantal angle. So we do not need a reference right triangle. We say that it is simply minus, so minus 5 miles. The y component is 0. It went neither north nor south, and so the y. So we annotate that. Then, so the b vector, what we must do is to draw a reference right triangle that includes components and y components, both of which will be negative. The b vector is in the third quadrant. So let's annotate that now. And we can see clearly that both the x and y components are negative. Here is the right triangle. What we have is that the x component is plus or minus, in this case will be minus. The polar magnitude, which is the hypotenuse of this reference right triangle, in this case 50 miles, the hypotenuse is the side opposite the right angle, the largest side in any right triangle, times the cosine of the reference angle, which is 45 degrees. The y component is plus or minus, in this case, minus hypotenuse or polar magnitude times the sine of the reference angle, again 45 degrees. And so we now fill that in. 50 miles times the cosine of 45 degrees. And for the y component, we write minus hypotenuse, or again 50 miles, but this time times the sine of 45 degrees. And then to add the y component separately, and equal to minus 60.36 miles We carry one extra significant figures for the problem. So we carry 4 so as to not propagate round off error. And then for the y component, we write down that r sub y is negative 35.36 miles. To be a third quadrant angle. And our calculations are consistent with this because r sub x is negative, which is consistent with a third quadrant angle, and r sub y is negative, also consistent with a third quadrant resultant angle. The third step, we now have the resultant vector in x and y component form, but while we calculate vectors in component form, we report vectors in 2 or more dimensions in polar form or magnitude and direction. The resultant vector, if we take the components that we would have r sub x is equal to minus 60.36, and then r sub y tail to tip is the minus 35.36 miles. And so here's the right angle. And then the resultant vector is from the first tail to the last tip of this right triangle. And so for that we get, let's see, the square root of minus 60.35.36, and that gives us 70 miles rounded to 3 significant figures. That is an inverse tangent, so that is the angle whose tangent is, of course, the reference angle is an acute angle. So we take the absolute value of the y component of the resultant over the x component of the resultant so as to get a first quadrant angle, and then we'll place it in the third quadrant. The angle whose tangent is absolute value 35.36 divided by minus 60.36, and that gives us an angle of 30.4 degrees. Resultant vector is in polar form. The rescue ship needs to sail miles at an angle of 30.4 degrees, and that is south of west. So south of west. And that's all.